Hello, everyone, and welcome to CSE132C. My name is Arun Kumar, and this is the Spring 2020 online-only edition. I hope everyone is staying safe wherever they are under this current lockdown situation, and hope everyone's health is in good shape and you're taking care of yourself. Um, put your health and safety first, but of course life has to go on and education has to go on, and so all faculty at UC San Diego have moved their courses to an online only format in keeping with the UCSD and state and federal guidelines for this season right now. Okay, so this is the introductory lecture where I will go over the logistics of this course and also give you an overview of what is to come in this course in terms of the schedule, and also provide you some information about the online only modality. So let's get started. A bit about myself first. Like I said, my name is Arun Kumar. I'm originally from southern India. I did my bachelor's in the city of Chennai, formerly called Madras, at the Indian Institute of Technology. And that picture over there is the Marina Beach, which is one of the largest beaches in the world. It's a large, flat, sandy beach. So I grew up with the beach. I'm pretty used to having the ocean next to me. And then I went to grad school in the University of Wisconsin-Madison in 2009 for my master's and PhD in computer science. And the picture there is the Capitol building. So Madison is the capital of the state of Wisconsin, and you get gorgeous fall colors in the upper Midwest. And so I enjoyed my time there for 7 years doing my master's and PhD. I graduated in summer of 2016 and joined UC San Diego. Of course, you see the UCSD picture over there. I joined the computer science department as an assistant professor. And then starting last year, I've also been part of the Halajolu Data Science Institute, HDSI. So I'm jointly affiliated. Another way to see this is I've experienced summers of up to 110 Fahrenheit with almost 100% humidity in Chennai. Not a fan of that. Then I went to Wisconsin, where I experienced winters of minus 40 Fahrenheit. It gets so cold because of these things called polar vortices that descend from the Arctic that you can throw a glass of hot water into the air and it will fall down as snow and ice. So not a fan of that either. So I'm really happy to have this happy middle between 50s, 60s, 70s throughout the year here in San Diego. So what is this course about? Why should you take it? Why would you want to, what would you learn from it? How many of you have heard of this contest called Jeopardy that used to be on TV? And of course, if this was an in-person class, I would ask you to raise your hand, but if in a recorded lecture, there's no one to raise your hand. So let me just move forward with this. So Jeopardy is a quiz contest in which the host states a fact, and then the contestants are asked to respond by posing a question. And a decade ago, IBM Research initiated the Watson project, which was this massive data processing and AI system that actually went up and competed against human champions, those two people over there, and actually defeated them roundly. And that was heralded as a major advance in AI and computing. How did Watson achieve that? Well, Watson processed huge amounts of data. So this is the architecture, the software system architecture for Watson from one of their papers. They call it the deep QA architecture. You can see that they have tons of databases that they used as input. These are databases about facts about the world, databases that they call evidence sources that help them with their reasoning, and then a lot of algorithms, probabilistic algorithms, AI algorithms, to crunch all this data into providing a confident answer. Second, now of course, pretty much everybody uses Google search these days. You go and search for something or someone, it displays a ranked list of web pages, of course. But then it also displays these things on the side called info boxes. Now the info boxes provide structured data about that person. So here we have our chancellor, Pradeep Khosla, and it says he was born at this date, from this location, and the name of the spouse, education, and so on. How does Google know that? Did anyone actually go in and sit in and enter all those details about Pradeep? Actually, no. Google has this project called Knowledge Vault that basically converts huge masses of databases, semi-structured and unstructured data, web pages and text, into structured tables. And these structured tables are basically obtained from a process called knowledge-based construction or information extraction. Okay, so by crunching large amounts of data, it was able to generate these structured knowledge graphs. Now, everybody probably uses online shopping. Now, I'm a big user of Amazon, and as you can see, it recommends products based on your prior purchase history. Now, this product that it's recommended was obviously from when I was at Wisconsin, so I don't think you would need a waterproof, windproof, insulated gloves in San Diego. However, the recommendation was pretty spot on. So how does Amazon know that? Well, again, Amazon processes huge amounts of data, structured databases about user behavior, my prior purchase history, other people's purchase history, and also features about the products. So they have catalogs of millions of products, all of which are crunched together into what is called a recommendation system that makes predictions about what users are likely to buy. And these are just a very small snapshot of modern applications of data systems technologies. There are innumerable traditional applications of database systems that define our modern world. And this includes transportation. Modern transportation systems would not be possible if we do not have very high, kind of low latency, high throughput booking systems for tickets and organizing passengers and so on. So pretty much all logistics firms, transportation firms use database systems. Banks, modern banking has given us a lot of convenience for online banking, app-based banking. All of that requires what is called transaction management. Again, a very central technical capability provided by database systems. Retail, we talked about e-retail, but physical retail in actual stores. And of course, amidst the lockdown, everybody needs to go to the actual stores to get whatever you want, toilet paper, eggs, whichever is available. And you need to pay with your cash or your credit cards, and somebody has to swipe it and make sure it works, and payment is recorded. These are called transactional databases, and retail companies are among the largest users of database systems. Think of, for example, Walmart or Target, recording every purchase by every person at every store across the world. And of course, insurance. I don't know if you know Flo, she is a very popular character in the US for insurance advertisement by Progressive. And insurance is another major user of database systems. It allowed us to organize data better, to scale up the capability of insurance and deliver services to people. So large-scale data management systems are the cornerstone of many digital applications, both modern and traditional. Modern includes stuff like web and Internet of Things. Traditional typically refers to enterprise, like finance, telecom, retail, insurance, and so on. And data management systems, data processing systems have only become more and more important as computing starts to become important. And this is now called the age of big data. And the term data science has emerged. I mentioned the Harley Data Science Institute. We've even formalized it as a department. The New York Times declared this the age of big data almost 8 years ago. And then, of course, Forbes magazine also talked about how pretty much all major businesses are drowning in a sea of digital information. And Harvard Business Review declared data scientist is the sexiest job of the 21st century. And so what I say is data everywhere, all the wallets that shrink. Everybody wants to purchase database this, data system that, machine learning system this, and the cloud computing technologies are making it more accessible. But data everywhere, nor any moment to think. Are you actually using systems correctly? Are you actually building the right kinds of data systems? How should these data systems work to enable us to process, store, query, and all of that when dealing with large amounts of digital data? That is what this course is about. CSE132C will get you thinking about the fundamentals of database systems. It goes beyond just understanding how to use a database system like SQL and relational model. That would be your CSE132A or your introductory database modeling course. Here, we will talk about what happens behind the scenes. How does the database system work that makes you access and manage and query and analyze all this large amounts of data? So there are largely 4 major parts to the topics in this course. Number 1, how are large structured data sets stored and organized? Now, there's an adage going that, oh, 95% of the world's data is all video now, so why should we care about structured data? Well, it turns out that more than 2/3 of business critical applications still deal with structured data. And these are based on surveys of data scientists done by Kaggle.com, which is like a massive data science portal. Think of any enterprise application, insurance, retail, finance, banks. They're not going to be conducting businesses just by video. They're going to need relational databases. They need to organize their data in a structured manner that can be consumed by people and dealt with precisely in digital form. Okay, so large scale structured data sets are never going to go away, and the database systems are going to remain fundamental for the digital world. 2, queries, how are they handled? Now, in your introductory database course, you might have taken SQL, the structured query language. In this course, we will see how is that actually executed by the database system. What happens once you give the SQL query string? How does it take it apart? How does it run it on your data software? How do you get the actual records processed and retrieved and returned to the user? Number 3, how do you make the system faster? Here we will talk about issues of query optimization. How do we make these queries that the user provides faster using database systems ideas? Now, one of the central advantages of database systems, in particular relational database systems, is what is called data independence. Users write query as if the data organization is not known to them. So the database system can organize the data however it wants to improve performance. It can do the access of the data however it wants to improve performance, all the while ensuring correctness and returning the same answers to the user's queries. And lastly, we'll talk about a few deeper and more recent issues. And this includes data flow systems, NoSQL stores, a huge movement that started a decade ago and has now fizzled out. They've eaten humble pie and they've accepted that SQL is still needed. Okay, let's now look for let's look at the logistical information for this course. Prerequisites, like I said, you need to have an introductory database course that you've taken, CSE132A, or its equivalent, either here at UCSD or elsewhere at another school. If you have not taken this, you need to justify why I should waive the prerequisite for you. And the prerequisite largely revolves around the relational data model, relational algebra, and SQL. Okay, so if you have, say, extensive practical experience with relational DBMSs in, say, some internship or some real world project or a company, then you can email me that justification, send me a brief paragraph, and then I'm happy to waive the prerequisite for you. If you have never worked with relational DBMSs and don't know relational algebra, I would highly recommend taking 132A first before taking this course. Now, from the system standpoint, CSE 120, which is the operating systems course, or DSE 102, the systems for scalable analytics that I created and taught for HDSI last quarter, will also be helpful for you, but these are not a prerequisite for this course. It's okay if you have not taken them. I will cover some of the systems foundations needed to understand database systems in this class. Lastly, C++ programming experience will help. C++ is a necessary component for the programming projects in this course. And if you know related languages, maybe you know C or Java, then C++ is probably easier for you to pick up on your own. Check the course webpage. The link is over there. It's already live, so you can go check it out. And you can see the tutorial link that I've given for C++ resources. If you only know Python or some other kind of high-level scripting languages, C++ might be a little difficult for you to pick up. So I would encourage you to go check out these resources before deciding whether you want to stay enrolled in this course or not. Now, the reason I emphasize C++ is it's one of the most common systems programming languages. Increasingly, they're saying Rust is becoming more common, but C++ still remains the king of systems programming. Maybe also C. Okay, what are the components of this course? There are basically 5 main things. 2 projects, programming projects, C++ programming projects. One involving, both of them involving implementing components of a typical RDBMS. So these are on top of a toy RDBMS kind of a toy RDBMS that we have called BadgerDB. You will be using the APIs of BadgerDB to implement a buffer manager component and a B+tree index component. And that accounts together 15 plus 25, 40%. And then there are 2 exams and a bunch of review quizzes. All the quizzes and exams will be delivered as online-only quizzes on Canvas. So Canvas is the learning management system for this class, and UCSD recommends this. I will show the Canvas link shortly. Now, the midterm exam and the final exam, the dates are as listed here. Midterm is on April 29th, final exam is on June 11th. These Canvas exams, there will be a time window during which you must take this exam. The exams are also time limited, and the same thing applies for the quizzes. They have a time limit. You have to take them in one continuous sitting within that time window. Okay, so all the quizzes and exams in this class are going to be open notes, open books, open internet. The only requirement is you do them only by yourself. Okay, so the review quizzes, there will be 6 of them. Roughly after every topic, I will have a review quiz. They are graded. Each quiz is worth 2% of the total score. I will keep only the best 5 out of the 6 review quizzes in this class. The review quizzes are going to be shorter. The exam slots are longer. Review quizzes will be about, say, 15 minutes most each quiz. The midterm exam is going to be for a full lecture slot length, which is 50 minutes. The final exam is, as per the registrar guideline, up to 3 hours, and the time window will be aligned with the final exam slot assigned for this course by the registrar office, which is on Thursday, June 11th. Grading scheme, I like to follow an absolute grading scheme. I don't like relative grading. I think it's a little bit toxic to a class. It pits students against each other. I don't like grading on a curve. My preference is absolute grading, where I give you absolute thresholds. And this time, because it's an online only edition, there might be some issues with the thresholds potentially. Maybe the edition is a little more difficult. So as a safety net, I also have a relative bin based grading as an option. And so the grading scheme is a hybrid. It's a very generous hybrid of these two. Whichever one gives you a better grade, that one will be used. Okay, so as an example, consider if your total score at the end of the class is 82 out of a total of 100, then in the absolute cutoff, 82 maps to a B plus grade. In the relative cutoff, let's say your percentile in the class is only 33 percentile, that puts you in a B minus bin. And so I take the better of the B plus and B minus, which is B plus, and so you will get the B plus grade. What does this mean? Because I like using the absolute cutoffs, if the entire class does really well, you put in the hard work that is needed to do the programming assignments, and you do well on the quizzes and exams, if everyone does really well, everyone deserves an A grade. Everyone can get an A grade. Okay, so that's why I like the absolute cutoff-based approach. What this also means is help out your peers on Piazza by answering their doubts and questions. Okay, so there is no reason to withhold help on Piazza approved help. Of course, you don't want to do unapproved, unauthorized help. That would be an academic integrity violation. Okay, so a little bit more about the programming projects. Like I said, you will be given an RDBMS skeleton called BadgerDB. It's written in C++. It was implemented by one of my ex-advisors and his TAs and students, Jignesh Patel at the University of Wisconsin-Madison. So he has generously agreed that I can use this in my classes, so we're using it. There are 2 main projects, Buffer Manager. You have to implement an algorithm called the clock algorithm that does buffer replacement. If it doesn't make sense to you what those words mean now, don't worry, we will cover buffer organization and buffer management in one of the class topics. Second project is a larger project and more difficult project, and that's the B+3 index. You have to implement the index data structure using the BadgerDB APIs, and you have to support inserts, deletes, and update operations on this index structure. Again, you don't have to worry about it for now. You don't know how these things work. We will cover it in the class, how index structures like this B+3 index work, and then you'll have to implement it in C++. The programming assignments will be handled by the teaching assistant. I will share the teaching assistant's name. I will be covering the conceptual and the algorithmic and the technical and the theoretical part in the lectures. The TA will be talking about BadgerDB and the project statements. Any questions about the code itself are best directed to the TA. If you have conceptual questions about the algorithms or the index data structures and efficiency or anything else, then you can feel free to ping me. But if your question is about some specific function and how do I use this argument, the TA is the best resource for this. Now, the programming projects in courses like these are complementary to the goals of the lectures and the conceptual part. You get hands-on experience. You get to get your hands dirty by going ahead and implementing these components in a mock real RDBMS. Whereas in the technical part of the class, the conceptual part, you will be dealing with more factual and conceptual questions, quantitative questions, technical questions, and those are the questions that will be covered in the quizzes and exams as well. Now for the projects, you can form teams of 2 people or an individual, so which is a team of 1 person, and you have to inform the TA of your team constitution. The deadline is listed on the course homepage. The link is available there, and there should be no sharing of code across teams. Okay, so you are allowed to discuss in conceptual terms with others on Piazza or by chatting with them about your general approach to the problem, about the technical or conceptual aspects of it, but you cannot share the code across teams. That is a violation of academic integrity. Do not look for code online and then try to copy it. Do not post your code online and kind of hand it out to others. All of that is a violation of academic integrity, and I take that very seriously. In past editions of this course, we have discovered academic integrity violations. The students were appropriately penalized. A common thing I would do is downgrade you to the lowest possible grade, and that would mean all the hard work you put in on the other aspects of the course will go down the drain because your grade will be the lowest possible grade. That is a pass grade. If the violation is more egregious, I will not hesitate to recommend that the university conduct investigations, and that might lead to serious consequences, including things appearing on your transcript, suspensions, and potentially even kicking you out of the university. Okay, so just to it's not that I want to scare you, but I just want to emphasize academic integrity is absolutely critical, in particular for this online only scenario where collusion between students is quite likely if they are not told of the importance of academic integrity. The Canvas quizzes that I'm going to offer for the exams and the quizzes in the class have mechanisms inbuilt that will prevent the possibility of collusion among students, and therefore I'm reasonably confident that the academic integrity measures I've taken will work for this particular class. Notice that if you are cheating is not fair to your classmates. Most students, vast majority of the students are honest and they want to take the class because they want to learn the subject matter. So if you cheat, you're not being fair to your classmates. And I will crack down on potential cheaters. Okay, that said, late days, the projects will have ample time assigned for you to work on them. And I will leave it to you how you want to coordinate it with your teammate, whether you want to meet regularly, whether you want to do it separately. It's joint responsibility. Both teammates are responsible for the code they submit, and they have to submit it on time by the deadline listed on the project page of the class. No late days will be given, so plan your work accordingly. Okay, so now that everyone is doing remote work, there's less time commuting and moving here and there, so hopefully that gives you more time to plan your work well. In the real world, there is no notion of late days. If you are in a job and you have to ship a product, and if the others finish their part and you fail to finish your part, you will be potentially fired. If you're a grad school, you're in research, if you don't meet the paper deadline or the proposal deadline, you will not be able to submit it. Okay, so the notion of late days is a luxury that probably the lower division courses will give you, but as you get closer to the real world, you need to learn to plan well upfront and deliver your thing on the deadline given. Okay, so see more details about the projects on the course project page. I will show it shortly. Okay, so now for the online only modality, there are 2 things that remain the same and 1 thing that's different. Even in a regular in-person class, we will use Canvas and Piazza. The online only modality, Zoom, is something new. So let me walk through these. Canvas is the one-stop shop. It's the learning management system recommended by UCSD. All course announcements will be posted there. Course pages, the homepage, schedule page, projects page, documents page, everything will be linked from Canvas pages. All meeting links will be posted there for the lectures, for the office hours. Now the meetings will be via Zoom. The lectures will be live meetings, so there's synchronous option. If you really want to join the Zoom meeting for the lectures, join the lecture Zoom meeting. I will be playing the recorded video for the lecture, so I will not be lecturing live during the Zoom meeting. However, I will be sitting there and answering questions. So you can feel free to join the live meetings, lectures, and interrupt and ask questions on Zoom. I will answer the questions during the live lecture slot. However, the videos will be available offline for asynchronous viewing, Students who are not in the same time zone or somewhere else can feel free to view the lecture videos, including this one, whenever they can. Okay, so please make sure to follow through the schedule page and keep up with the schedule of the rest of the class. Do not bundle and postpone lecture viewing to, say, closer to the exam date or something like that. The quizzes are also there to help you kind of force, as a forcing function, to make you review the materials in a periodic and timely fashion. Now, one request is I will be posting Zoom links on Piazza and on Canvas. These are private links. Please do not make them public. These are only open to students enrolled in this class. Piazza page for this class is also private. It's only for enrolled students, and all these are for capacity reasons. There is an access code for Piazza that is posted on the Canvas page of this course. So go to the announcements. Now, I have also automatically enrolled students who have signed up on WebReg or have been approved by me on the Easy portal. The staff seem to have some delay with the Easy portal, VPN access, there's some issues. Officially, you will be enrolled on Monday or Tuesday. All recorded video lectures like this one, talks, lectures, talk videos, discussion videos, review exercise videos that I post, everything will be linked to from the course schedule page. It'll be hosted on YouTube and it'll be available as public videos. The video files will also be made available under the files folder of Canvas of this course. And the main reason for that is sometimes YouTube may not be available from some locations. Maybe it's not available from China, for example. And so not all students may be able to access it. Canvas, on the other hand, should be accessible from anywhere in the world, and you should be able to view the videos there. Finally, some administrivia. The lecture slot, like I said, is the assigned slot. It's 1 to 1:50 p.m. Pacific time, Monday, Wednesday, and Friday. I will be hosting a video viewing during this live lecture slot, and I will be available live to answer questions. So if you are interested in asking questions and looking at the video during the slot, feel free to join. If you don't want to do that, you want to do it asynchronously, you're welcome to do that too. Major questions during the lecture viewing slot, I will try to summarize and post it afterwards on Piazza. Okay, so please make sure to follow the Piazza post of this class. That's my email ID over there, my office hours, Wednesday 3 to 4. Again, it'll be on Zoom only, and I will send the link privately. Okay, so keep track of the Canvas page announcements, and project submissions will also be on Canvas. Grade releases will also be on Canvas. And that's the link for the Piazza page. And that's the name and contact information of the TA, Palash Chauhan. He will be in charge of the BadgerDB programming projects.